For 5-axis simultaneous milling, DFS 2013 now has the ability to smooth the azimuth and elevation axes independently, using one of several smoothing options. One such option is the new stepped stabilization smoothing. This type of smoothing will stabilize the rotary axis movement by maintaining a fixed tool axis as much as possible within an angular range. The toolpath will appear as a series of 3+2 axis segments with 5-axis transitions between them. The transitions can either be completed on the surface or with a lift. So we have an example here with some pre-made features, and what each feature is doing is it's doing a pencil mill along this fillet, along the base of this boss. We'll take a look at these. I'll turn off all but the first feature and go into the attributes here. There's no smoothing in this example. This is just a pencil mill with no smoothing. It's turned off. You can see that we're using a lean angle of 45 degrees. And in these corners where we might have some gouge issues, we're using a lead avoidance technique. Okay, let's take a look at this toolpath in centerline. The tool comes in, and I'll turn this a little bit. I'll single block this, and you can see that it does a nice job going along the fillet. When it gets up into these ridges, though, you can see a tremendous amount of movement, both in the azimuth and in the elevation, as it tries to negotiate that shape. This is further pronounced if I show this to you in machine simulation. I'll go ahead and stop this, go to Machine Sim, and single step. We're using the Hermele C30 post, so this is a standard post. If you don't have this machine design or this machine simulation show up for you when you run this demonstration, you can browse to the 5-axis folder and you'll be able to find this post. I'll single step this, and once again you'll be able to see all of this action as the table and the trunnion are moving back and forth to accommodate this cutter path. Okay, so I'll go ahead and stop that. You get the idea of how that affects the toolpath and how that affects the axis movement. I'll stop that and we'll go to our next option here. The next option is still using a pencil mill, but we're using the step smoothing technique, but we're only affecting the elevation. So I'll go in here and edit the attributes, go to the axis smoothing tab, and you can see stepped on surface, and it's only affecting, again, the elevation. And we have this maximum angular correction of 3 degrees, so that's that angular range we were talking about. The azimuth is not being affected or corrected in any way, and we have a smoothing distance of 20 millimeters. So we'll start again with the centerline simulation. Okay, it comes in. It's still going to wobble quite a bit, though. The tool is going to move less in terms of elevation, but the azimuth has not been affected at all. So we have still a lot of movement with these tool axes. Okay, I'll stop that and once again show this with the machine simulation. Okay, so you get the idea of that, the change that made. Really not much of a change. It's really only affecting the elevation, not the azimuth. The next feature is pencil milling using the stepped smoothing, and we are affecting the azimuth and the elevation with links. So what this will do is it will try to maintain a 3+2 toolpath in segments, and when it has to reposition the part, the tool will lift off, the part will move, and then the tool will re-engage the work. So I'll show you what this looks like in centerline first. Okay, so what you can see happening here is the tool moves, it comes off, repositions, moves again, repositions, on through these areas where it has to transition. So that's that sort of progressive 3+2 segments of toolpath. You'll notice that in that segment right there, it was able to maintain a single orientation for longer. It's mostly around the outside corners where it has to do the most repositioning. All right, I'll let that play on through. And I'll take my part to transparent here so that you can see these toolpaths. Again, it's mostly affecting outside corners here in this area here. It did not have the transition. And then on these larger corners, you see quite a few transitions in these lifts as the tool loops with the step overs. And again with the machine simulation. The machine simulation is very helpful in this case because you can see that more of an incremental move of the azimuth there. Basically moves and stops between each segment of toolpath. All right, now play that on through. Okay, I'll stop this and go to our last option here. Pencil milling with the step smoothing, azimuth and elevation on surface. So this will not have the lifts. The tool will stay on the surface throughout this. I'm going to go look at the attributes here and the axis smoothing. You can see stepped on surface for both azimuth and elevation. And we have a much broader maximum angular correction here. So that will be a larger range that will give us fewer indexing moves of the part. Okay, so the tool stays in contact with the work. It moves, and you can see that right through there with that larger range, that larger angular range, we have a pretty constant 5-axis position through those areas. And this is the most stable option yet, where we have a wide angular range. We're keeping that tool on the work. Finally, our last machine simulation, you'll be able to see this in action. I'll just play this through. Okay, and that's the different options for the new stepped stabilization smoothing.